Let's take a look at an example problem using Coulombs law. Now you guys know me, we're going to do a complicated one, so the easy ones are easy. And so this one starts out and we have three charges placed on the corners of an equilateral triangle. Charge 1 is 5 microcoulombs, charge 2 is negative 8 microcoulombs, and charge 3 is 10 microcoulombs. What is the net force on 3? Doesn't really matter what order you put these in, but I'm going to go 1, 2, 3. So charge 1 is 5 microcoulombs, 5 microcoulombs. Charge 2 is negative 8 microcoulombs, and then this one is 10 microcoulombs. Now what you have to pay attention to is Coulomb's law, F equals Q1, Q2, K over R squared, does not tell you the direction of a force. It tells you the magnitude of a force. You kind of got to use your free body diagram to determine the directions. So I'm interested in 3. This is a positive charge, this is a positive charge. So I have this force, which I'm going to call the force of object 1 on 3, and it points up and to the right. And then I have this force, which is the force of 2 on 3, F2 on 3, and it points towards charge 2 because those have opposite charges. So once I find these two forces, then I can find their vector sum to figure out what the net force is on charge 3. It should be to the right and either up or down depending on which one is bigger. It'll probably be down because these two charges are bigger, these two charges are smaller. So let's go ahead and get started. First I'm going to find the force of 1 on 3. So the force of charge 1 on charge 3 is given by Q1, which is, or Q2 I guess, no, Q1, sorry, which is 5, times Q2, which is 10. Okay, but I've got to be careful with these because these are microcoulombs. So really what I have is 5 times 10 to the negative 6 times 10 times 10 to the negative 6 divided by the distance between them squared. Oh, and I forgot to tell you that this equilateral triangle is 10 centimeters per side. So the distance between them is 0.1 meters, and if I square that, that's 0.1 squared, and then I multiply by k, 9 times 10 to the ninth. Now 5 times 10 is 50, and so I have 50 times 10 to the negative 12 divided by 0.1 squared. And then I have to multiply that 9 times 10 to the negative ninth, or to the positive ninth, and that gets me a force of 45 newtons. Okay? Now what direction is that? Well, that is along this line, which is a 60-degree angle above horizontal. So I'm going to say F1 on 3 is equal to 45 newtons at 60 degrees. Then I'm going to go ahead and I'm going to switch over to this second force, and so the force of 2 on 3 is given by 10 times 10 to the negative 6th times 8 times 10 to the negative 6 divided by 0.1 squared times 9 times 10 to the ninth. Okay, 8 times 10 is 80, so I have 80 to the negative 12th, or times 10 to the negative 12th, divided by 0.1 squared, or the same thing as multiplying by 100, and then multiply that, 9 times 10 to the ninth, and we see 72. Okay, and so just like we said, this force is bigger because the two charges over here are bigger. And this is directed at negative 60 degrees. So I have 72 newtons at negative 60 degrees, which means I can put that all together in sort of, well, I'm going to use x and y components. So F13 has an x component and a y component. Let me make my table a different way. So F13 and F2 on 3. Okay, so F13 has an x component and a y component. And the x component of F1 on 3 is 45 times the cosine of 60, and then the y component would be times the sine of 60. So 22.5 and 38.97. Now both of these are positive because it's up and right. The other one, F2 on 3, we have 72 at negative 60, and so the x component is positive, but the y component is going to be negative. So 72 sine negative 70, negative 60 is negative 62.35. And then I can just add up everything here. So 22.5 plus 36 gets me 58.5 newtons in the x direction. This one, 38.97 minus 62.35 gets me 23.38. And so then I can just put all that together into one final answer, and this is negative. So my final, the net force of the two charges on my first charge, 58.5, 23.38, and so my resultant force is right here, and that has a total of 63 newtons, and then at this angle, so the angle whose tangent is 23.38 divided by 58.5, which is 21.8 degrees. So I'd say 63 newtons at negative 21.8 degrees. And that does make sense. It is being pulled towards this charge because this charge is bigger than this charge, and these two charges repel. Okay? So it's going to head this way towards that charge.